Hello, welcome to the course Excelling with Mathematical Modeling. In this lecture, we continue with our study for this estimation of parameters, and today we will be learning about how to estimate the parameters with a discrete difference equation in the discrete cases. So, what you will be given is again a set of data, because it is a discrete case. So, it is n 0, 1, 2 and so on, and some variable x n, and this data will be given, say x 1, x 2, x 3 and so on. And you will be having a discrete equation of the form x n plus 1 some x n, which contains the parameters. We will be using the same method of least squares to estimate the value of the unknown parameters. So, straightforward, we go to the Excel spreadsheet, but before that let me tell you what equation we will be doing. So, I will be taking the logistic growth equation in discrete case, and the equation looks like a n plus 1 is equal to a n plus some b times c minus a n into a n, where b and c are unknown parameters. This b is the intrinsic growth rate and c is the carrying capacity. So, let us go to the data. So, this is the measured value of some growth data. So, let us first see that how this graph looks. So, this is the graph. So, I just see this is say some growth curve. So, the equation which I have is the logistic equation, and this will look like this, that a n plus 1 equal to a n plus b times c minus a n multiplied by a n. And I just make this font 20. So, this is the equation. B and C is the unknown parameters. Now, as I can see that this curve is going towards the value 600 and above, and here I can see it is 621. So, one way is that I can take this value directly to be 621. So, that I know my carrying capacity from the graph, as it is going to 621. Then the only thing is that what will be the value of this C. So, the predicted A n so this is the predicted A n, the initial value, say I coincide with, say I put it as 10. So, this will be equal to a(n). If I put 0 here, so it is a1 equal to a0 plus b times c minus a0 into a0. Now, this is equal to a0, which is this, plus b times, so I have to put a value here, say 0.1. This is equal to a0 plus b times, which is a constant, multiplied by c. So, I already took the value of c to be 621 minus a0, which is this, and multiplied by again a0. So, I get this value. Okay. Okay, let us now plot these values first. So, I have to come here, I have to select data, and I have to add data. This is the predicted. So, the values of n, enter, and the values of predicted. Okay. So, let us make this continuous line. So, change the chart type, the predicted or the continuous line. Okay. Open the legend, remove the grid lines, and this series 1, I rename it as data. Edit. Okay. So, now you can play with this value a little so that this curves comes here. So, 0.001. Okay. Oh, wow. Okay. So, if you put some value here, so as I was started playing with, I see that this becomes quite a good match here. But then now you have to check using the method of least squares. So, first you calculate residuals, so the residuals is this value minus this value. And then the residual square. So, this square. once you get the residual square, you have to calculate the sum. So, which is equal to the sum of the square of the residuals. So, I got the sum. So, since this is quite a good match, this value is not going to change much. So, that was just a guess and it sort of matches very well. But then the technique remains the same. You go to, once you get the sum of the square of the residuals, you have to minimize this, go to data, go to solver, and then in this objective, I choose this one, which is this cell. I have to minimize, and by changing the variable cell, which is B here, and I will click solve. So, a very slight change, and you see the value is 0.00097. So, that is why it was a good match, because I just put 0.001. So, that is why it becomes a good match, and from here you can see that it is a quite good match with this particular set of data and the estimated value for B, because I have taken the C value to be 621. So, the estimated value of B is 0.00097,452. Let us quickly take another example where I have this E. coli data, and I am going to the one which we used for the continuous case. So, only I make the time, this is n now, and this is some growth data a n. So, I make them 20 and this. So, in this particular case also I will, since it is a growth data, I will be using logistic equation, but now here I will estimate both B and C. So, I just put it, say some 0.1 and 0.1. So, the reason of choosing such a less value, you see the data and see where it is approaching. So, they are all 0 point something. So, that is why instead of choosing 1, 2 or something, I choose some value which lies somewhere in this range. And I know that the logistic value, that it will ultimately go to its carrying capacity. So, let us see. So, it is approaching to some value, as you can see, 0.7 something. So, I could have taken it as 0.7 also, but then let us estimate it. So, the first thing is, this is the measured. So, you got the growth data from some experiment. So, this is the measured A n, and now the predicted A n. I take this value to be 001, and then this value is A0, which is this, plus B times, which is a constant, multiplied by C times, again a constant, minus A0 multiplied by A0. Oh, so this will be D4. Yeah, so you get some value. So I drag them, make them 20. So let us now plot this. However, I should have plotted the measured value first, but since we are doing it for previous examples, so let's now draw all three of them at the same time. I go to insert, I go to chart, and say I have this chart. Name it again as growth curve. So this one, let's change it to series type. So this one as a continuous line. And let me remove the grid lines. The legends are here. So I go to design, select data, now series 1, edit, name it as data, and series 2, edit, name it as predicted. So this is the data, this is the predicted. Not a very good match, but you have to play with the values. So you have a B and a C. So let's take the value of this to 0.5. Okay. So once I change these values to 0.5 and 5, I see this curve is going up. Let me remove this one so that you can have a look here. Yeah. So 0.6, it's again moving up, again 0.6. So slowly you can see that if I adjust it, I can bring it somewhere here. But then let's see the sum of the residuals. So this is equal to the measured value minus the predicted value, and I square them. So sum, this is the square of the residuals, so sometimes if suddenly this comes, don't panic. What happens is that you just click double click and you get the rest of the values here. So if they're quite small, actually what happens is the values are approximate to certain decimal places. Now I have to get the sum. So this is equal to the sum of the squares. So now this is the data, this is the predicted value. I have to estimate. So I will using solver. I go to data, then click solver, and I have to minimize the sum of the square of the residuals. So here this is the value, sum of the square of the residuals. I have to minimize the value by changing the variables of B and C, rest remains same. I click solve, okay. So you can see it's a quite a pretty good match. Because this is embedded here, you cannot see it, but let me see if I can change the chart type. Yeah. So if I just change it from dots, you can see that this is the blue one is the data and the orange one is the predicted. It's a pretty good match, and the values are 0.77 and 0.79 of B and C. B is the intrinsic growth rate and C is the carrying capacity. So, using this Excel spreadsheet, you can calculate or you can estimate the value of the parameters of your model equations, whether it is differential equations or whether it is a difference equation, and you can move on with the modeling part. So, with this we come to the end of this lecture of estimation of parameters. In my next lecture, we will be looking into something different. It is called the simulation modeling. Till then, bye bye.